Okay, so 2.2, we're still on the basics of functions in their graph. This is basically like a part two. It's a continuation. And so looking at this first part, we're still, all about functions. So it says use the graph of f to find the indicated function values. So this is the f function here. And so it's asking us to find f of negative 2. So if you remember, that's just a fancy way of saying let x equal negative 2. So we don't have an equation to plug it into. Instead, we look on the graph and we look at, okay, when x is negative 2, that ordered pair correlates with negative 4. And so that's actually the answer. That's what f of negative 2 is equal to. It's equal to negative 4. That's our actual answer right there. And so the next one's f of 4. So once again, where x equals 4, and that correlates with y equaling positive 4. And then f of negative 3 right there, the y value is 0 when x is negative 3. Okay, I got another graph. We have some similar questions here. So they call it the g of negative 4. So our function is right here, y equals g of x. So just function notation, same thing as y, it's just function notation. So let's see, g of negative 4, when x is negative 4, y is 2. G of negative 10, well, that's off the graph, but you can see that we have a straight line and we have an arrow on the end, so it indicates that it just indefinitely goes out that direction right there. So if you were to go out to negative 10, it would still be at a height of 2. So we're going to go ahead and put that at 2 right there. And then the last one, they're actually, let me go ahead and read this first. For what value of x is g of x equal to negative 1? Remember, this is just a fancy way of saying y. So they're asking you for x, and then this time, this example, they go ahead and tell you what the y value is. So they're telling you that y equals 1, so they're actually asking us for what is the x value. So looking at the graph, when y equals 1, that would correlate with when x is negative 2. So that's our answer right there, negative 2. Okay, so this next part that we're going to look at, they're going to give us a graph, and then we have to determine the domain, the range, x-intercepts, y-intercepts, if there are any, because some of our graphs might not have those. And then it says find the missing function value indicated by the question mark below each graph. And so basically what we just got done doing right there, where they tell you, okay, f of negative 3, when x is negative 3, what's the y value? Okay, so let's see, the first one they're asking you right here, our domain. Remember, domain is just a fancy way of asking you for your x values of your ordered pairs. And so let's see, we should have, let's see, negative 4, negative 3, negative 2, negative 1, 0, 1, 2. So those are all our x values right there, our domain values. Okay, then our range values look like we go from 1, we go to 2, we go to 3, we go to 4. And some of those ordered pairs have the same value twice. You don't need to list it twice though. So let's see, 1, 2, 3, 4. Then let's see, x-intercepts. Let's see, so do we touch the x-axis? No, so we don't have one there. And then let's see, y-intercept. We do hit the y-axis right there. And so I can't quite recall how they're going to ask this on your homework. They might ask you for the ordered pair, so it would be at 0, 2, or they might have it in set notation where you just put 2. Okay, so it might ask you either way. So just look at the directions when you're doing your homework to make sure you input it the right way. And then the function value, let's see, f of negative 3, that's going to correlate with positive 3. Okay, so this first graph this is known as a discrete graph. And that's because we just have, ordered pairs kind of spaced out. Um, the rest of the graphs are going to be known as continuous graphs. And the difference is discrete graphs, there's only so many points. You could actually count them. There could even be, thousands or millions of points, but you could count them. But on these other graphs we're going to look at, they're known as continuous, and there's actually infinitely many points right between these two endpoints right here, okay? Because there's a straight line going across, and so there's infinitely many points. So when I'm asked to list my domain, it's kind of, you can't just say -3 and then -2, -1, and so on, because you're missing all the decimals in the middle, and there's an infinite amount that you could do. And so for example, between 1 and 2, you could say 1.1, 1.11, 1.111, and you can just keep adding an extra decimal place. And so there's infinitely many um, ordered pairs here. And so we're asked to figure out the domain, which are the x values. Well, the x values look like they're going to go from -3 to 5 and everything in between. And so that's where we're going to use our interval notation from our first unit. So the interval notation, we're going to use brackets because we're going to include the endpoints. We're going to go from -3 all the way to +5. So if you were to pick out any point on this line, the x value would be somewhere between those 2 points, and it could possibly be one of those points. Now for range, we're going to see how low do we go. Well, the lowest y value we have is 1, and the highest y value we have is 4. And so that range is anything you could, if you pick any point on the line, the y value could be anywhere between 1 and 4. And so let's see, 1 comma 4. And there we go. X-intercept, once again, we don't have one for this particular graph. We do have a y-intercept right here at 3. Once again, you might be asked to put it as an ordered pair, or we might be doing set notation where they just ask you to list any intercepts that you see. Let me clean that up. A little brace. There we go. And then our function value, let's see, f of 5. When x equals 5, it looks like y is going to be equal to 1. Okay, so I've got about 4, maybe 5 more of these continuous graphs. We'll go ahead and look at those with the same type of questions. So here we are. Okay, so this time once again, we're back to domain. And so if you look at this graph is actually known as a parabola. And so parabolas, they either go up or down pretty quickly. But the thing is, it's always gonna go to the left though. Might kind of go slowly, but it's always moving to the left. And then on my right side of my graph, as I'm going up, yeah, I'm going up pretty fast, but I'm always moving to the right also. And so the domain on this particular graph is really, there's nothing excluded. So it's everything from negative to positive infinity, because it goes out in both directions from left to right, okay? So whenever we're talking about domain, you're just focused on from left to right, okay? I know it's going up or whatever, but don't worry about that. You're just focused on, okay, as I follow my graph from left to right, it would go left forever and it will go right forever. So there's no values that are not included. Now for the range, that's a little different. Remember, range, you're going to go from bottom to top, okay? So the lowest point we have is right here at -4, and then whichever way you go, you just kind of go up pretty quickly. Whether you go left or right, the graph shoots up to positive infinity. So the range is going to be from -4 to infinity, okay? And we include -4. The only reason we wouldn't include a value is if we see an open circle on the graph. And we might see an example of that in a moment. Okay, x-intercept, we actually have 2 of them. We have one right here at 1, and we have another one here at -3. So once again, we could list this as ordered pairs, okay? Or we could do set notation. So set notation, you would just list where it hits the x-axis. Do not put parentheses around it. Those are braces for a set notation. You don't want to put parentheses around it because that's a lot different if you do this. This indicates an ordered pair on the graph. That would be this point right here, or up here, right up there. And so uh, we want to make sure we're indicating the x-intercepts and we're using the right notation. So you don't want to do it like that with parentheses. Okay, y-intercept, we have one down here at -3. So 0, -3, or might have set notation. And then the function value, so let's see, f of -2, that correlates with -3. And they gave us a bonus one, f of +2, and that looks like that correlates with 5. There we are. Okay, this next one's really quite similar to the one we just did. The only difference is this is known as an absolute value function. It's a V shape, but we're going to get similar results from the one we just completed. So the domain is going to be from negative to positive infinity, because once again, you can kind of see it goes left and right for each direction indefinitely, and then we cover everything in the middle here. Okay, now my range, on the other hand, I dip down to -1, and then whichever path I take, I end up going up forever to positive infinity. Okay, and let's see, x-intercepts. I don't see any on this particular graph. I do have a y-intercept at 1. And then our function notation, looks like we got 2 of them again. So f of -1, that looks like that's going to correlate with 2. And then f of 3, that correlates with 4. All right, and these take a little bit of time. Once you really get it down, you'll find these actually quite easy, but at first, it can be a little confusing and take a little bit of time, especially the domain and range part. Okay, our next one, we can actually see one where we have an open circle, okay? The other one, it's kind of hard to tell, but it looks like it's closed. We're going to assume that one's closed, okay? And so the first part is domain. So yes, I know it's curving up and everything, but on domain, just kind of worry about left to right, okay? And so a lot of students make a mistake. They focus on this -1 right here, but really that ordered pair right here is at 0, -1, and domain, we focus on the x values. So we go right here, we go from 0 all the way to 5, but not including 5. That's what all the x values, if you follow this line up here, the x value goes from 0 to 1 to 2 to 3 to 4, all the way up to 5, but not including 5. We got that open circle right there. So the domain is going to be from 0 to 5, and then we'll put an open parentheses with 5. So we're approaching 5, but we don't include it. So that means you get to include everything as you get really close, just not 5 itself. Then range is going to be the y values. So our y value down here is -1, then we go to 0, 1, 2, 3, 4, and we get up to 5, but once again, we have an open circle, so we're not actually going to include 5. So we're going to go from -1 all the way up to 5, and I have to do a parentheses there. X-intercepts, it looks like we got one right there at 2. So 2, 0, or set notation. And then let's see, our y-intercept looks like we have one right there at 0, -1. Okay, and then find the function value f of 3. So f of 3 looks like that's going to correlate with 1. All right, let's see. Okay, I think I just got 2 more of these, and then we'll see what we have next after that. Okay, so back to domain. So remember, domain's just our x values. So our x value looks like we're starting at 0 right here, right? It correlates with 0. And then this thing just is going to go on in depth indefinitely to the right. So that's going to be infinity. So our domain is going to be from 0 to infinity. Now our range, we start right up here at 1. And yes, I'm going to the right pretty quickly, but I'm also going up kind of slowly, but it is going up, and it will go up indefinitely. If you were to follow it forever, it's going to continue going up. So our range, our y values are going to, the lowest one's going to be 1, and there is no, sometimes they'll call it upper bound. There's no upper bound. There's nothing holding us from going up. So we go up towards infinity. Okay, infinity is just a concept. It's not an actual number. It's just that we increase indefinitely. We just keep going up. All right, x-intercept, I don't see one. Y-intercept, we got one at 1. Let's see. And then function value f of 4. Let's see, that will correlate with 3. Okay, so I got one more like this. Okay, so domain, let's see. So going to the left, let's focus on the left. So let's see, it's going, I know it's going down, but I'm more focused that it's going to the left indefinitely to negative infinity. Then we cover everything in the middle of the graph, and then I go to the right forever to positive infinity. So the domain should be from negative to positive infinity. Okay, range on the other hand, let's see, is there a bottom? Basically, there's no bottom because it doesn't bottom out basically because it's going left, but it's going down, and it will go down indefinitely. So it goes down to negative infinity, but there is a ceiling. The highest point we reach, so down from the biggest negative number you could ever think of, and then we rise up and we only make it to -2, and then we flatten out and just stay there at -2. We don't go any higher. So that's going to be from negative infinity to -2, and we do include it because those points are included here. All right, x-intercept, I don't see any. Y-intercept, I got one there at -2. And then let's see, function notation, f of -4. Let's see, that will correlate with -5, it looks like. And then f of +4. Let's see, that will correlate with -2. And when you're doing your homework, you should, the graphs will look kind of small on your screen, but you should be able to enlarge them, and that'll make your life a little bit easier, okay? So don't get too discouraged. The domain and range stuff, it's one of those topics that until you get it, it can be quite frustrating. But once it clicks in place, you're going to find domain and range to be pretty simple. So I'm going to go ahead and stop the video here, but I'm going to create a part 2 for these other examples I have down below.